whether they will be able to attend. Okay, so welcome everyone to this session. So like I said yesterday, we're going to talk about the estimation of a population proportion under stratified random sampling. So we are going to estimate the population proportion. We're going to estimate also the estimated variance of the estimated population proportion. Then later we are going to show you how to calculate the sample size required to estimate the population proportion, and then place a bound on the error of that estimation. So those are the three important things that we are going to do. Then after we do the related examples. So it's very important to attend, because we won't repeat it again. Next time we're going to move on to the next topic. So without any waste of time, let me just go to the window journal so that we can share the board. Just wait a bit while I'm going there. Okay. There we are. There we are. So it's lecture number 13. Lecture number 13. Okay. Like I said, we're going to estimate. That is the estimation of a population proportion. Remember, it's under stratified random sampling. Okay. So how do you estimate the population proportion under stratified random sampling? Okay. You use this formula to estimate the population proportion under stratified random sampling. You use PST estimate. Okay. It shows that you are estimating the population proportion under stratified random sampling, which is given by 1 over n, the summation of ni pi. So an estimate. So where I as usual is ranging from 1 up to r. Okay. And the capital letter N is the population size. Capital letter Ni is the population size for each stratum. And pi hat is the estimated population proportion for each stratum. Okay. So now the estimated variance of the estimated population proportion under stratified random sampling. So how do we calculate that? The estimated variance of the estimated population proportion under stratified random sampling is given by var estimated one, so PST hat. Otherwise, it's the estimated population proportion under stratified random sampling, which is equivalent to 1 over n squared. Okay, the summation I is ranging from 1 up to r of ni squared, open brackets, Ni minus Ni divided by Ni, close brackets, Pi estimate, Qi estimate divided by Ni minus 1. So this is the formula that you can use when you want to estimate the variance of the estimated population proportion under stratified random sample. Okay, so this can also be written as, let me just scroll down a bit. Sorry for that. Scroll down a bit. Okay, so this can also be equivalent to 1 over n squared. The summation I is ranging from 1 up to L of Ni squared, open brackets, Ni minus Ni divided by Ni, close brackets, and Pi hat, open brackets, 1 minus Pi hat, isn't it? You know that Qi is the same as 1 minus Pi hat. Then you divide everything here by Ni minus 1. So it's the same as that one above. So this is the formula that you can use to estimate the variance of the estimated population proportion under stratified random sampling. Okay, so another thing is to show you how do you calculate the sample size required to estimate the population proportion with a bound on the error of estimation under stratified random sampling. How do you do that? Okay, sample size required to estimate the population proportion with a bound on error of estimation, with bound on the error of estimation. So it's given by this formula is n, which is the overall sample size, which is equivalent to the summation of Ni squared Pi Qi all divided by Ai. Remember, I is ranging from 1 up to L. Okay, then you divide everything, okay, by n squared times d. Now our d here is a bound because we're estimating the population proportion. Estimated population proportion. So our bound here, actually we're supposed to have a d here. So let's just replace this d by what? B squared over 4, isn't it? Let's replace it by b squared over 4. Then what? Plus the summation of Ni Pi Qi. I is ranging from 1 up to R as usual. So this is the overall. This is the overall sample size required to estimate the population proportion with a bound on the error of estimation. Okay, so in this regard, you know that our AI stands for what? If you still recall. AI is the what? It's the fraction of observation. The fraction of observation for stratum I. For stratum I. Okay, isn't it? And PI, like I said, is what? It's the population proportion for stratum I, or for each stratum. Okay. PI is the population proportion for stratum I, for each stratum, in other words. So this is the formula that you can use to calculate the sample size, the overall sample size required to estimate the population proportion and stratified random sampling. Any question before we move on? None. Okay. So now let us go to the sample size for stratum at a minimum cost and population proportions. In other words, it's NI. Sample size for each stratum using the cost under stratified random sampling. Okay, let me just go to the next page. Okay, is the sample size for stratum at minimum cost. Okay, so in other words, you're going to find the sample sizes for each stratum, N1, N2, and N3. So generally, you have to find Ni. Okay, so Ni is given by Ni times the square root of Pi Qi. Okay, then all divided by the square root of Ci. Okay, then divided by the summation, where I is ranging from 1 up to L of Ni, the square root of Pi Qi. And again, you divide by what? By the square root of Ci. Okay, then you multiply, because this one is the sample size for each stratum, you multiply by the overall sample size. Multiply by the overall sample size. So, like I said, if you still recall, Ni can also be equal to N times Ai. Still remember?
Yes, sir.
Okay, so that's it. So in Neyman, if you are dealing, this one now is when we have the cost, or the costs are different, or the costs are not the same. But if the costs are the same, so that means you're going to have your sample size for each stratum like this. So your Ni is going to be equal to what? To Ni times the square root of Pi Qi. Okay. Let me just, okay. Let me just write it down here. Can't fit here. Okay. So let me just write it here. Ni equal to Ni, okay, times the square root of Pi Qi, okay, then divided by the summation of Ni times the square root of Pi Qi, then multiply by what? By n. So now here we don't have a cos, or in other words, the cos are the same. The cos are the same. So this one now comes from Neymar allocation, if you still recall. Let's check the upper one. Let me just scroll up here. Sorry. See this one? So when the codes are different, but you want to calculate what? The sample size for each strata under population proportion. Okay? If the codes are the same, so you use this formula. So in other words, it's like you are applying Neyman allocation because the codes are the same or are equal. Okay, now let's quickly go to the example so that you can apply this. Okay, let's start with example 4.6 on the lecture notes. Example 4.6. So on page 29. Example 4.6, page 29, lecture notes. Okay. So again, we are just applying example 4.1. It's the continuation of example 4.1. So we have got the population size 310, which is divided into 3 strata. Okay, which is town A, and then town B, then rural area C. And you know that the population size for town A is what? 155. Okay. And then again, according to that example, we have been given a sample sizes. So N1 is equal to 20. Okay. Then you've been given the table there, table 4.2. Okay. Which shows the word stratum 1, 2, 3, sample size N1, N2, and N3. Then the number of households viewing show X. For stratum 1 is 16, stratum 2, 6, 2, stratum 3, 6. So in that regard, you have to calculate the estimated population proportion. So let me just fill this dramatically thing. Then later we are going to calculate the estimated population proportion for each strata. And I'm going to write that table 4.2 down so that you can see clearly. So now let's just go to town B. Town B, the population size, which is N2, is what? Is 62. I think you are familiar with this one. Sample size from the table N2 is 2. It's 8. 8. Okay. Then coming to rural area C, the population size for rural area C N3 is 93. So the sample size for rural area C is 12. Okay. These are the information that are given. Now, from table 4.2, let me just write it down here below this one. Okay, table 4.2. We have been given the stratum. In other words, it's town A, town B, and rural area C. There are 3. So it's 1, 2, and 3. Okay. Then sample sizes. Then the number of households viewing show X. The number of households viewing show X. Let me just call it X. So sample size for stratum number 1 is 20. Number 2 is 8. Stratum 3 is 6. So the number of households viewing show X for stratum number 1 is 16. Stratum number 2, there are only 2. For stratum number 3, there are 6. Okay. So those are the information given. So now we want to find the estimated population proportion. In other words, is P I hat.
Sir,
See that one? Yes.
you made a mistake at N3. It's 12, not 6.
Oh, yes. Thank you very much. Thank you. That means you're around. Thank you for that. So it's 12. Okay. So now we just want to find the estimated population proportions for each stratum. So in other words, you have to find P1 estimate, P2 estimate, and P3 estimate. You can tell me, what is the P1 estimate? The estimated population proportion for stratum number 1 is what? It's X1 over N1, which is what?
0.8.
0.8. In other words, it's 16 over what? 20, isn't it? So it's 0.8. For stratum number 2,
Zero point 0.25.
0.25.
0.25. Stratum number 3,
0.5.
0.5. So in other words, here up there, sorry, here you can just find what? P1 hat, which is 0.8, P2 hat 0.25, and P3 at, which is what? 0.5, isn't it? Yes, that's it. So that's it. So now you have those information now. According to example 4.6, it says what? Estimate the population proportion of households viewing show X and place a bound on the error of estimation. We're estimating the population proportion of households viewing show X. Remember, it's under stratified random sampling, so it's PST estimate, okay? Which is equal to what? 1 over n summation. I is ranging from 1 up to what? 3, because there are 3 strata. Then Ni Pi. Okay. So in other words, we are going to find what? We have to find Ni Pi at first. Okay. Which is equivalent to what? N1 P1 at, N2 P2 at, N3 P3 at. And then you give me the answer. The answer there. Can you do that?
I got 154.
154. Okay. So we said you get 154. So that means here. So 1 over overall population size 310, isn't it? Multiply by 154, like you said. What is the answer?
I got 0.497.
So everybody agree? Mine is different.
Isn't it 0.6?
Yes, myself I got 0.6. So please just check yours.
How?
How? Okay, let's do it so that you
Is
can see how.
154 correct?
So you said 154. Let me check. 154 divided by
I made a
310.
mistake.
The inside part,
I
inside
said
part is
I said
186.
So that
yeah,
means it's not one.
it's
Tell me.
186.
Yeah, the
136.
inside part is 186.
Well, I made a mistake. I said 115 instead of 155.
Oh, okay. It's 136 divided by 310.
186.
186.
Or 186. Okay. 186 divided by 310. Yeah, 0.6. So what I got it. Got the same answer. Okay, that's it. Then, so we have to find a bound. Né? To find a bound, we must calculate the estimated population proportion, estimated variance of the estimated population proportion. Okay, first. In other words, you have to find the estimated var of the estimated population proportion under stratified. Okay, which is what? 1 over n squared summation I 3 of ni squared ni minus ni divided by ni for pi 1 minus pi So divided by what? Ni minus 1. So this is the formula that you have to use. Estimated variance. So okay, so let's plug everything. So you have got 1 over 310, isn't it? Then you square it. Okay. Then you find the population size for stratum number 1, which is 155. Then you square it. Okay. Then the population size for stratum number 1, which is 155. Then you subtract what? The sample size, which is what? 20, isn't it? Then divided by what? By 155. Close the brackets. And the proportion, estimated proportion of stratum number 1, it was what? 0,8, isn't it? Then 1 minus 0,8 is 0,2. Then you divide by what? The sample size minus 1, which is 20 minus 1, so you're going to have 19. Okay, that's number 1. Plus, so you go to the second stratum. The sample size for the second stratum is 62. So you're going to have because I don't have a space here, so let me just write it below here. It's 62 squared. Okay, then 62 minus what? The sample size for stratum number 2 is 8, ne? Yes, it's 8. Then divide by what? By 62. Okay, then you close the brackets. Then the population proportion for stratum number 2 said is 0,25, isn't it? So 0,25. So 0,25, 1 minus 0,25 is 0,75. Put it there. Then you divide by what? By sample size minus 1, which is 8 minus 1. So it's going to be 7. Okay. Then you said plus. We go to the last one. Okay. Plus the population size for the last stratum is what? It's 93. Then you square it. So it's 93 minus the sample size, which is 12. Okay. Then you divide by 93. Okay. Close the brackets. Then the proportion of that got 0,5. 0,5. 1 minus 0,5 is 0,5. Okay. Then you divide by sample size minus 1, which is 12 minus 1, so it's 11. Okay. Then you close everything. So can you please calculate for me the final answer there?
I don't know if it's correct, but I got 0.004548.
Yeah, that's correct. That's correct. Thank you very much. So the final answer here is 0,00. If you didn't get it right, please just go and verify. But this is the final answer, I think. Then you have got the estimated population proportion under stratified random sampling. So You continue to find the what? The bound now. Find the bound. So your B is equal to what? 2 times the square root of the estimated var of PST estimate, isn't it? Which is equal to 2 times the square root of 0,0045. So what did you get?
0.139.
0,138
135.
135. Yes, that's true. So that's the bound that we're talking about. Then this one, example 4.7, is too long, so I rather not start today. So let me say we're going to start it next week because it's very long. We have to calculate until to the end. So I don't want to calculate another part and then another part I finish it next time. So it's going to confuse you. We have to start it and then we finish at the same time. Any question before I say goodbye and good luck for the test?
Even with test 2, we are going to get formula sheets, right?
Yeah, obviously.
Thank you.
So the previous formula sheet, it helped you, or you used it?
Yeah, it helped
No,
here and there.
that test was very simple.
So
Isn't
is
it?
there any chance of having test 3, Yana? Is
Are
there
you
any
talking about
chance?
test? Are you talking about test 3 now?
Yeah,
Before we write test 2?
please reconsider.
Isn't that we are going to check after you have written test number, let's say test number 2, is then that you can think about that. But for now it's too early, isn't it?
Okay.
But anyway, I think that the test number 1 was not bad. So it's rather maybe you made some mistake there, here and there.
Yeah, mistakes is an issue.
Okay. No, anyway, we'll see. Okay, can I stop here?